Section: Introduction. In this section, we present an overview of InternLM-XComposer-2.5, IXC 2.5, performance on various benchmarks in different domains, such as video benchmarks, structural high-resolution benchmarks, general visual QA benchmarks, multi-true multi-image benchmark, and web page crafting benchmark. IXC 2.5, based on InternLM-2.7b, not only matches but also surpasses GPT-4v and Gemini Pro in 15 benchmarks. Recent progress in large language models, LLMs, has led to the development of large vision language models, LVLMs. Leading models like GPT-4, Gemini Pro 1.5, and Claude 3 have expanded the applications of LLMs significantly. Open-source LVLMs are also being developed rapidly and can compete with proprietary APIs in several benchmarks. However, these open-source models still lack the versatility of closed-source leading models. They struggle with diverse vision language tasks due to limited training data diversity and challenges in handling long context input and output. To bridge the gap between proprietary APIs and open-source LVLMs, we introduce InternLM-XComposer-2.5, IXC 2.5, a versatile LVLM supporting long-contextual input and output with diverse comprehension and composition capabilities. IXC 2.5 excels in existing open-source LVLMs with two main advantages: versatility and long context capabilities in both input and output. It is trained with 24K interleaved image text data, extendable to 96K through positional encoding extrapolation, enabling enhanced human-AI interaction and content creation. Compared to its previous version, IXC 2.5 has improved in three comprehension abilities: ultra-high-resolution understanding, fine-grained video understanding, and multi-turn multi-image dialogue. Additionally, IXC 2.5 supports crafting web pages and composing high-quality text-image articles. We evaluated the versatility of IXC 2.5 across 28 benchmarks, where it outperformed previous open-source LVLMs in 16 benchmarks based on InternLM-2.7b backend. The performance of IXC 2.5 matches or even surpasses proprietary APIs like GPT-4v and Gemini Pro in 16 benchmarks. The IXC 2.5 web demo now includes audio input and output capabilities using open-source tools. Section Summary. In this section, we introduce InternLM-XComposer-2.5, IXC 2.5, a large vision language model, LVLM, that excels in various benchmarks, surpassing leading paradigms like GPT-4v and Gemini Pro in 15 benchmarks. IXC 2.5 stands out for its versatility in tasks like text-image conversation, video understanding, web page crafting, and its long context capabilities supporting multi-turn multi-image dialogue, high-resolution image analysis, and preference alignment techniques for stable response results. Section: Method. In this section, we present our model architecture, which is based on InternLM-XComposer-2.5, IXC 2.5. Our model follows the design of InternLM-XComposer-2 and InternLM-XComposer-2.5 KHD, IXC2 and IXC 2.4 KHD, incorporating a vision encoder, a large language model, and partial LoRa for alignment efficiency. We recommend referring to the IXC2 and IXC 2.4 KHD papers for more detailed information. Our IXC 2.5 supports various input types such as text, single, multiple images, and videos. We use a unified dynamic image partition strategy for videos and multiple images with different resolutions and aspect ratios. For image processing, we adopt the dynamic image partition and global local format design from IXC 2.4 KHD with some adjustments. In the vision encoder, we enhance the resolution to 560 by 560 to have 400 tokens per sub-image. For high-resolution images, we use a scaled identity strategy. When processing multiple images, we assign an index to each image and format them interleaved with text. In video processing, we sample frames and concatenate them to form a high-resolution image, including the frame index for temporal context. For audio input and output in the IXC2.5 web demo, we use Whisper for audio-to-text transcription and Mellow TTS for text-to-audio conversion. During pre-training, the large language model, LLM, is kept fixed while fine-tuning the vision encoder and partial LoRa to align visual tokens with the LLM. We use clip-vit L14-490 as the vision encoder and increase its resolution to 560 by 560. In supervised fine-tuning, we adjust the unified dynamic image partition strategy to handle larger images and videos. The model is trained with large images concatenated with up to 64 frames. We jointly train all components with specific learning strategies, considering data from multiple sources in a weighted manner. Each component has its unique learning strategy, with the vision encoder and LLM having specific adjustments to balance preserving original capabilities and aligning with vision knowledge. Section Summary. In this section, we present the model architecture of IXC2.5, which is based on InternLM-XComposer-2 and InternLM-XComposer-2.5 HD, incorporating a vision encoder, large language model, and partial LoRa for alignment efficiency. Our model supports various input modalities like text, single, multiple images, and videos, utilizing strategies such as unified dynamic image partition for videos and images, dynamic image partition, and global local format for image processing. During pre-training, the vision encoder and partial LoRa are fine-tuned to align with the large language model, employing strategies like clip-vit L14-490 and a layer-wise learning rate decay. Section: Web Page Generation. In this section, we have expanded the capabilities of the IXC2.5 by adding automated web page generation features. Our goal was to enable the IXC2.5 to create web pages independently using HTML, CSS, and JavaScript based on input like visual screenshots, free-form instructions, or resume documents. We noticed that existing open-source language models struggle with generating HTML and CSS compared to natural language tasks. To address this, we propose training the model using datasets from website version 0.1, v0.2, and Stack v2, followed by fine-tuning with a smaller dataset focused on instruction-aware web page generation and personal page examples. For the screenshot-to-code task, we pre-processed HTML and CSS code from the Stack v2 dataset to train the model effectively. We combined CSS and HTML code, removed comments, JavaScript, and unused CSS styles, and converted files into screenshots for processing. After filtering out low-quality web pages, we were left with around 250,000 high-quality pages for training the LoRa model. We set the LoRa rank to 512 and trained it over a single epoch with specific learning rate adjustments. To improve instruction-aware web page generation, we used GPT-4 to generate diverse instructions for web page creation and Claude 3 Sonnet for actual page generation. This approach resulted in 18,000 high-quality instruction-aware samples. Additionally, we utilized Tailwind CSS for its concise nature. We also introduced a task where the model generates a personal homepage from a resume, enhancing content organization and visual appeal. By leveraging GPT-4 and Claude 3 Sonnet, we created a dataset of 2,000 samples for this task and fine-tuned the LoRa model for 10 epochs. Furthermore, we discussed the importance of generating high-quality text-image articles for AI assistants, emphasizing their applications in education and entertainment. To achieve this, we proposed a pipeline that combines supervised fine-tuning, reward modeling, preference data collection, and DPO alignment for stable article generation. By rephrasing prompts using the COT technique and training models on augmented data, we improved long-form response generation. Through preference data collection and DPO alignment, we refined the model's performance in generating high-quality articles. Section Summary. In this section, we enhance the IXC 2.5 capabilities by enabling automated web page generation. We train models using datasets like Website and Stack v2 to improve HTML and CSS generation, introduce instruction-aware web page and resume to homepage generation tasks, and fine-tune the LoRa model for these tasks. Additionally, we propose a scalable pipeline for high-quality text-image article generation, incorporating supervised fine-tuning, reward modeling, preference data collection, and DPO alignment to improve stability and quality in generating articles. Section: Experiments. In this section, we validated the performance of our InternLM-XComposer-2.5, IXC 2.5, after fine-tuning it with supervision. We compared IXC 2.5 with various benchmarks, including both closed-source APIs and state-of-the-art open-source LVLMs of similar model size. We assessed its performance on tasks like video understanding, structural high-resolution tasks, general visual question answering, multi-image dialogue, and web page crafting. Our evaluation was mainly done using the OpenCompass VLM Eval Kit for consistent result reproduction. When looking at video understanding benchmarks, IXC 2.5 showed strong performance, surpassing open-source models on 4 out of 5 benchmarks and matching closed-source APIs. For instance, on MV-Bench, IXC 2.5 outperformed previous methods like VideoChat 2-7b and GPT-4v by significant margins. In structural high-resolution tasks, IXC 2.5 performed comparably to large LVLMs with fewer parameters, excelling in tasks like DOC-VQA, Wiki Table Question, Deepform, and TabFact. In multi-image multi-turn dialogue tasks, IXC 2.5 demonstrated superior performance compared to previous open-source models. Additionally, in general visual question answering benchmarks, IXC 2.5 performed exceptionally well, even outperforming models like GPT-4v and Gemini Pro in some cases. Lastly, in the screenshot-to-code benchmark, IXC 2.5 showed promising results, surpassing GPT-4v on average, showcasing its potential in translating visual designs into code effectively.